Hey everyone, my name's Steve, and today I'm going to show you how you can encrypt and decrypt files on IPFS. IPFS is really great for decentralized storage. It's used in NFTs and Web3 applications all the time. Although there is one small problem, I guess you could say. Pretty much all the data is public. If you have access to the CID, then you have access to the content. And depending on the content, that can be kind of a problem. For instance, if you wanted to token gate some content, you want to make sure no one can just download that content if they don't hold the NFT or token or something like that. But thanks to platforms like Lit Protocol, you can actually encrypt the file based on particular access mechanisms and then decrypt them if you meet those requirements. So in today's tutorial, we're going to show you how you can do exactly that. We're going to build an app that can take files, encrypt them, upload them to IPFS, and then take them from IPFS and decrypt them if you meet the requirements. It's really, really cool, and I can't wait to show you guys. So let's go ahead and dig in. So the first thing you'll want to go ahead and do is actually make a Pinata account. It's really easy. It's free. Just go to app.pinata.cloud. You can sign up. Once you have an account, the first thing you want to do is go ahead and create an API key. You can do so by clicking on the API keys page, clicking on new key, give it a name, and you can decide what permissions you want if you want to scope them. I'm just going to say admin and then generate key. It's going to give you three things. It's going to give you the API key secret, and the JWT. Make sure that you save the JWT. That's what we're going to use in our app. The other thing you want to get is the gateway. If you click on the gateways tab here, you'll see you have a domain here of turquoise, tremendous tarantula, something. Yours will probably be different. They're randomly generated. You're just going to go ahead and copy that and write it down somewhere. We're going to use that in the app as well. Once you've got all that information, we want to go ahead and go to the terminal, and we're actually going to use a startup template that Pinata's already made. You can check it out with the link here. And it's essentially going to be a Next.js starter template that has uploading to Pinata already built in. And the great thing about it is that it uses Next.js's API routes, so all of your keys are kept in the backend, everything's kept safe. It's very, very nice. And to get started, all you have to do is just do npx create Pinata app. And from here, we're going to go ahead and give it a name. So we'll just call it an encryption app. You can choose if you want TypeScript or JavaScript. I'm going to choose TypeScript. You can also choose if you want Tailwind or not. I say, why not? We love Tailwind. At least I do. Don't hate. All right, so once we have that built, we can go ahead and just cd into that encryption app. And the first thing we're going to go ahead and do is actually install our Lit Protocol dependencies. This is what's going to give us the encryption bits. So we're going to do npm install. And it's going to be at Lit Protocol, Lit Node Client at Cayenne. So we'll just go ahead and install that. All right, and once that's installed, you'll want to just go ahead and open this up with the code editor of your choice. Once you open up the code, there's going to be a file called env.sample. You want to go ahead and open that up. And this is where we're going to go ahead and pass in some of the variables that we made earlier. So the first one's going to be the Pinata JWT, so you can just go ahead and paste that in. The other one is going to be the next public gateway URL. So the format that's going to take is just HTTPS, and then it's going to be that domain that we had earlier. So for me, it's the turquoise tremendous tarantula 668.mypinata.cloud. And that's it. Once you have that file saved, the next thing you want to do is rename it. So we're going to rename this from env.sample to env.local. And that's going to keep it from getting uploaded into our future Git repos. And it's also going to make sure it runs on our app. Now to actually start building this thing, we're going to go ahead and go into the pages folder and then go into index.tsx. And this is where everything pretty much is. We have all of our file upload functionality, as well as some front end. So you can see where we have all of our buttons and stuff. So uploads are already in there. And the first thing we're going to do is go ahead and import some of our Lit Protocol dependencies. So to do that, we'll do import, and we'll just do star as lit lit.js SDK from at Lit Protocol Lit Node Client. There we go. If you scroll down, you'll see we have the home component here, and we're going to set a new state variable. We're going to do const, and this is going to be kind of for later, but it's going to be decryption CID and set decryption CID. And we'll just make that an empty string, and we'll save that for later. So like I said, the great thing about this app is that it already has uploads built in. You can see here we have this upload file function that uses the API routes to API/files with our file that we're trying to upload. And so to do our encryption bit, all we have to do is just encrypt it before we upload it. Really simple. We'll just do it inside the upload file function. So right under set uploading, we're going to do const lit node client. That's going to be equal to new lit JS SDK dot lit node client. And we're going to open that up. And inside of it, we're going to do lit network IAN. So with Lit Protocol, there's actually several different networks that they do encryption on with different levels of decentralization and things like that. So definitely check those out if you're really interested. Cayenne is kind of like the default one. It's kind of like the test one. All right. And once we have that, we're going to go ahead and set up our connection. So we're going to do await lit node client dot connect. And this will basically let us connect to the Cayenne network. And then we're going to get an authorization signature. This is going to be from the user's wallet. That's going to get their identity and basically allow them to sign and encrypt these files. So we're going to do const auth sig equals await lit JS SDK dot check and sign message. And inside of here, we're going to just do chain Ethereum. And we do that in strings. Yeah, there we go. Now we have that set up and our user has signed our message, the next thing we're going to do is basically define our access controls. This is what defines who can decrypt this file. And there's a lot of different options here. We can make it token gated to a particular 721 NFT. We can have a balance of a particular ERC20 token. You can do direct addresses. It's really cool. The ones we're going to set up is just going to be kind of more of a test one. It's going to be if you have either equal to or greater than a balance of 0 Ethereum. Pretty much everybody, right? Everybody has a 0 balance if they sign the message, right? So the way we do that was to do const ACCS, kind of stands for access equals, and this is going to be an array. And inside the array, we're going to have an object. We're going to say contract address. We're going to make that empty strings. And then we're going to have standard contract type. We'll make that empty strings as well. Most of this is just kind of boilerplate, so if you wanted to copy and paste this from the blog post, you certainly can. We'll do Ethereum is our chain method. And we're just going to do that ETH underscore get balance. So we're getting the balance of how much Ethereum they have. And we'll do parameters. And we'll do semicolon user address, comma, and we'll do latest. There we go. And return values. Return value test. That's going to see what do they have that allows us to give them access. And we're going to see comparator. And we're basically going to do greater than or equal to as our compare operator. And then we're going to do value 0. There we go. Now that we have everything set up for encryption, it's actually time to take care of the encryption itself. And so this is the really fun part. Basically going to do const encrypted zip. And now there's a lot of different options for encryption. If you just wanted to do strings, you could do that. The nice thing with a zip file is that it allows us to store all sorts of helpful metadata and things about the file that we uploaded that helps make it rendered correctly on the other side. Some things that you may want when it comes to IPFS. So we're going to basically do encrypted zip equals await lit JS SDK encrypt file and zip with metadata. Very fun. We're going to go ahead and do our object inside of here. I'm going to do access control conditions. Do ACCS. Oops, turned it into a thing there. All right. And our auth sig is going to be our auth sig. Oh, Make sure we spell it correctly. And we're going to do chain Ethereum file. And this is where we're going to pass in the file that we originally get the file to upload. So file to upload our lit node client, which is what we made earlier. So we're just going to literally pass it in double like that. Very, very easy. And then we can also attach a README. So we can actually include some information for the person who downloads this folder and be like, what the heck am I supposed to do with this thing? We could say use our IPFS encryption app to decrypt the file. So to make it acceptable for our API, we're actually going to go ahead and do a little formatting here. So we're going to do const encrypted blob equals new blob. And in here, we're going to put in our encrypted zip. And we're going to make it a type of, and we're going to do text plain. And then we're going to do a file out of that blob. So we're going to do const encrypted file equals new file. Works almost exactly the same way. Very easy. And we'll put in our encrypted zip. Or encrypted blob, I mean. There we go. And we're also going to pass in a name. So we're going to do the original file to upload dot name. There we go. And now what we're going to go ahead and do is inside of our original form, we're going to take out the file to upload and we're going to do encrypted file. And there we go. So all that together, we basically have something that's going to upload the file and encrypt it. The next thing we want to do is go ahead and make a new function to decrypt a file based on a CID, which is going to be very, very cool. So we're going to just go below the upload file function. We're going to do a new one called const decrypt file. Ooh, here we go. And it's going to be an async function. I'm going to pass in a file to decrypt. There we go. And we'll do a try catch in here. Pass in our error. So inside this function, we're going to do a few things. First thing we're going to do is go ahead and get the file off of IPFS, and we're going to do that using our dedicated gateway. So to do that, we'll just do const file res equals await fetch. And we're going to do backticks here, and we can go ahead and do $ brackets, do process .env .next. Gotta make sure you spell it right. Public gateway URL, and then we're going to do /IPFS, and we're going to pass in the file to decrypt. So we're going to do $ brackets again, file to decrypt, which is basically just a CID, and we're going to add on one more query parameter here called file name. And this will just help that our, SDK and everything is able to understand it correctly through Lit Protocol. We're just going to call it encrypted.zip. That can be really whatever you want, but this is probably the easiest way to do it. And once we have our file res, we're going to do const file equals await file res dot blob. That function there. So now we have our file. So now that we have the file, we're going to basically rebuild our whole LitNode client connection and auth signature for the person to sign, showing that they own the file. Let's move this down a bit. So what we're going to do is say const LitNode client equals lit JS SDK. Oops. Let's try that again. Lit JS SDK. There we go. And we're going to do lit node client, open it up, we'll say lit network, pass in cayenne again, all stuff that we did earlier. Let's say await lit node client dot connect, and then we do our auth sig with const auth sig equals await lit JS SDK dot check and sign message. And we'll do chain Ethereum. So now that we have our connection and our signature, now we can basically use the inverse of what we use to decrypt, and that's going to be to encrypt, and that's going to be the decrypt. So we'll just do const decrypted file metadata. We're going to basically extract these objects out of our request. So we'll do await lit JS SDK, and we're going to do decrypt zip file with metadata. And we're just going to pass in file as file that we just got from our gateway. We're also going to do our lit node client, pass that in. And we're going to get our auth sig. There we go. All right, so we got our decrypted file and our metadata. Now we basically need to make it accessible and let people download it. So to do that, we're going to basically make a new blob. So const blob equals new blob. And you guessed it, we're going to pass in the decrypted file. There we go. And we're going to do a type of application / tet stream. Oh, and let's change that to blob, not blog. And once we have that, we're going to do a download link. So essentially what will happen is after someone has actually decrypted this file, we'll just automatically download it to their downloads folder, and they can just start looking at it. And you can handle this file differently. If you wanted to show the file itself in some kind of modal, you could do that. It's really up to you. But we're going to do a const download link equals document, and do create element. And we're going to basically do an A tag, just like a regular link, href link. So we're going to do download link.href equals url.create object URL. And we're going to basically pass in our blob. Oh. Ref, not hreg. And then we'll do download link.download. And we're going to use metadata, not .name. Now, this is really important because when you're using any kind of file, because that's the thing, IPFS can handle any kind of file type, but the trick is when you encrypt and decrypt it, there's got to be some information about what kind of file it is and how it's interpreted on your computer. You know, if I have a picture, but I rename it to picture.txt instead of PNG, my computer's not gonna be able to open it. It's gonna do some weird stuff. And so what's great about this upload with zip and decrypt with zip is that it's maintaining all of that important information about the file intact. And so you can literally do 3D files, PDFs, you name it. You'll be able to make sure that they're downloaded and rendered correctly on the other person's computer. Really cool stuff. I really like it. So we got the name in there, and now the last thing to do is just do download link.click. And that's it. Now, one last thing we actually need to do is this function is not being used in the front end at all. So we need to go ahead and make something real quick. So I'm just going to go down here. So what I can do here is just go ahead and add another set of inputs and buttons here. And I'm not going to copy, or I'm not going to type all this out. I'm just going to copy and paste it. You can get this from the blog post if you want. But essentially I'm going to do a input with a text, type of text, and we're going to do an event and set the decryption CID. And then we'll have a button to decrypt the file. So once we've pasted into CID and hit decrypt, it's going to make us sign the message, make sure that we're allowed to decrypt it, and then finally give us the file. So let's go check it out. All right, so we've got our app running. This is basically the Next.js template layout. Very fun, very pretty. And we did npm run dev from the terminal. And if you have any problems with this, definitely start with at least the authentication piece, so your ENV file. Make sure all of that is rocking and rolling, ready to go. But you can see here we have our upload button. If I click on it, I'm just going to go ahead and select this image of Penny. And what's going to happen is actually going to prompt me to connect MetaMask. And so I'm going to go ahead and connect a wallet. And then I'm actually going to do a sign-in request with my wallet. And this is basically going to sign me as the encryptor, etc., that this file is now encrypted. Once we have it, we can go ahead and copy the CID and paste it, click Decrypt. And since we already signed that message, it's going to take our auth signature from earlier and it's just going to go ahead and download it. Pretty sweet. Now, everything we covered in this video is actually already been done in a blog post. So if you prefer written format, you can go ahead and visit it with the link below and just go step by step. Even includes a template that's completed and ready to go. So you can start working with this little encryption setup. And one thing that's really cool in this post is I actually have some different access control settings that you can maybe take a look at. So for instance, if you wanted to only let someone who has a specific ERC-721 token, you can use something like this where it checks a contract address, ERC-721, it's going to do the balance of user address and it's greater than 0, right? Pretty easy. You could do stuff like DAO memberships, or even if you just want it to be sent to a particular address. Really, really cool stuff. Well, that wraps up our tutorial. I hope you guys enjoyed it. If you have any thoughts, comments, or questions, feel free to leave them in the comments below. And until next time, happy pinning.